Okay, so welcome to my presentation, Configuration, a Webpack Story. So this is part two of a two-part series. The first part, which was last month, was over task runners and bundlers leading into Webpack. We were going over some history of it. Don't worry, it's not a prerequisite to this presentation. You will still be able to follow everything that I talk about today. But I would still encourage for you to, check it out afterwards, just so that we kind of get full circle context. And I will be recapping it in a few slides. So like I said, it's not a prerequisite. So about me, my name is Fabian Buentello. Here's my Twitter handle in case anyone wants to get in contact with me or reach out. I'm a senior front-end developer at Dragos. Dragos is an industrial cybersecurity company primarily focused on protecting critical infrastructure. Sorry, that's a mouthful for me. And so pretty much what that means is we protect your rail system, your electrical grid, traffic lights. These are the systems that you really don't want, for those to get compromised. Something about me, I'm a former iOS developer. I've been doing iOS since 2012. I've been doing iOS and JavaScript since 2012, and just recently in the past year moved over to JavaScript 100%. So let's recap what we talked about last time. Like I said, I'm gonna bring you up to speed if you haven't seen it or if you haven't checked it out. So let's recap. Before Webpack, before task runners, bundlers, let's just like a manual setup. Meaning, like, what you want to do is you want to write Sass code and have CSS come out the other side. Okay. The way that you would do it is you would of course download the Sass tool, the command line tool using npm, and what you would then do is do Sass. You would pass in an input, and then you would tell it where to write it to, an output. Okay. So it's three parts, the input, the tools, and then the output. So with that idea, let's bring in task runners. On the left-hand side, we have Grunt. Grunt was created by Ben Aumann in 2012. And on the right-hand side, we have Gulp, which is created by Eric Schofstall in 2013. Now, what you see here in the middle, I'm going to describe it like the anatomy of a task. You have, with the task, you would pass in somewhere to read, you would pass in a path for it to read from. It would then do something with whatever data that it got, and then you would tell it where to write it to. Okay, just pattern here if you're kind of seeing it. So let's look at this in practice. I know there's a lot going on this screen, but don't worry, just look at it in the way that we kind of talked about it, where you have input, you have the tool, and then you have the output on the other side. So in our task runner file, we have tasks, and these tasks, I'm using them as blocks, but these are like snippets of code. We're going to have a Sass task to handle our Sass transformations. We'll also have another task for Browserify and Babel. That's going to be for our JavaScript. Now, let's look at this system work. So we're going to be passing in our Sass. So pretty much when I say pass in, we're telling it to read from this directory. It's going to then do its thing. It's going to spit out a minified CSS file, right? And then we tell it where to write it to. So in this case, we're telling it to write into the styles directory inside our dis folder. We're going to do the same thing with our JavaScript, but now we're transpiling from like ES6 or ES7 down to browser compatible code. And again, we're going to tell it to write to the source directory. The next two tasks are pretty interesting because they don't necessarily follow the same input tool output type of pattern that I was talking about. But the watch task, which is the third one here, this is something that in Webpack you kind of take for granted. When you make a change for a file and you save it with Webpack, it automatically redoes everything for you, right? You don't have to think twice about it. Well, in the past, you actually had to configure the task runner and tell it which directories to read from. So in this case, we're going to be watching these two directories, okay? And so the green light or the green outline is pretty much saying that this task is live right now. Like it's constant, right? It's alive. The last one is our dev server. That this is kind of like what we're used to now with Webpack. We'll have like a little dev server configuration. So, all right, now the dev server's up. Our application is loaded up in localhost 8080. All right. And so now let's go back to the code. All right, so now let's say we want to make a change to one of our SAS files. Well, then here's the pattern, or not the pattern, but the steps that happens. So what just ended up happening, and we're going to do it again with the JavaScript, don't worry, but we made a change to our SAS file. Our watch task caught it, and we configured our watch task we told it, hey, if anything changes inside of this styles directory, I want you to first run the SAS task, write the output to the styles directory, and then reload our dev server. Now we're going to do the same thing with our JavaScript here, but instead of the SAS task, we're going to run our Browserify in Babel. So we made a change, spat out, and then we reload our dev server. If that looked like a lot, then good, because that was the point of this slide. There was a lot of configuring when it came to task runners, so much so that whenever you cracked open one of these files, you were very intimidated because you saw a lot of code to where, especially like if you made a change here in this task, it could affect a task down the road that was dependent on its output. So, all right, if I scared you off, don't worry. Okay, I promise you that this presentation was going to be about Webpack, so I just needed to do a quick recap or what we talked about last time. Now, I'm sorry for those who came to my previous presentation because I'm going to have to reuse some content, but don't worry, I'm still going to switch things up for you. So Webpack was created by Tobias Copper. Here's his Twitter handle. It was created in 2012. Now, for those of you who are familiar with your JavaScript history, know that a red flag should have been raised because we associate Webpack to React, but React wasn't created or wasn't announced till a year later in 2013. So when I saw this date, I automatically was like, wait, hold on. How did Webpack get created before React? So I reached out to Tobias and he sent me the link and he pretty much told me about this presentation that was done by Pete Hunt. Pete at the time was part of the Instagram team at Facebook, and the presentation talks about the issues or the problems or challenges that his team was encountering during the build process with their product. Here's a fun fact about about Webpack. Webpack is actually a fork of Modules WebMake. Now, it all started in issue number 7 and Modules WebMake in 2012. Tobias wanted code splitting. That's all he wanted to add to Modules WebMake. But clearly it did not go through, and it was ultimately decided that he was going to fork the repo and create his own project, which then later became Webpack. If you compare the two, here on the right is Modules WebMake in their documentation. I don't know about you, but that kind of resembles a loader. I don't know, not exactly, but I mean it kind of, yeah. But all right. Let's start breaking down a configuration file, what we came here for, right? So let's go ahead and let's talk about the entry point here. In fact, actually, before we're going in that, take a snapshot of this real quick in your mind. Tell me, in your mind, don't say it out loud just yet, but what's missing? All right, what you typically see in your Webpack files, what's not in here is what I want you to think about, and we're going to revisit it in a bit. So with Webpack, we pass in an entry point or a file, right? One file. From this one file, Webpack builds your entire application. Now, how it does that is that this file imports other files. Now, I'm going to switch out the word file with the word module. That's the first important word that I want you to take away tonight. So these modules import other modules, and these modules import other modules. By the end of it, what you have is called a dependency graph. Now, take note of like the modules here. Like, yes, some of them are just plain old JavaScript. Others are node module files or node modules. Others are Sass, fonts, images. Like a module can be anything at this point. This is just an idea. So hopefully by seeing this and explaining this image from Webpack's website makes a little bit more sense. Whenever you see here on the left-hand side, that's the dependency graph that it's describing. So the next important word is resolving. So Webpack resolves your dependency graph And the way that it does that is by treating, even though it's a Sass file, even though it's an image or a font, it treats every single one of them as if they were JavaScript modules. So that's a concept that, or not, but that's something that keep that in mind as we continue. So now you're gonna be seeing the icon here is gonna change. This little green, that's I think it's the node image or the node icon. So now now Webpack's gonna be resolving these modules. So resolves the first one, and it's just valid JavaScript. Webpack doesn't have a problem parsing it out. So what it ends up doing is it spits out a bundle.js, all right? So look how small, it's small, okay? Then it resolves this node module. So then our bundle gets a little bit bigger. Then it resolves another JavaScript module, and so our bundle gets a little bit bigger. What happens next is something that we've all seen. Module parse failed, unexpected token. And what it's pointing to is the less than character inside of your JSX. So how does Webpack resolve this module? Because again, it treats everything as if it was a JavaScript module. The thing is, this is no longer valid JavaScript. The way we tell Webpack how to resolve it is by using loaders. So now we're going to be bringing in our Babel loader here, and inside you see the presets. So we're using the preset React and the env. And notice how we're excluding the node module. Again, Webpack does not need a loader in order to resolve those. So that's why we exclude it, because Webpack can do it automatically. So there's no need to make it pass through our Babel loader. So, all right. So our bundle got a little bit bigger. Next, we're going to be resolving this Sass, or this JavaScript module, which really underneath it is Sass. The way we do that is by using the Sass loader. Now, here's one thing that I'm not too fond of when it comes to Webpack, and we're going to be talking about it later on, about programming practice in configuration files, but we'll talk about that later. But so with Webpack, the way it executes, or the way it runs its loaders, is from the bottom up. So in reality, what's going on here is what you see down here at the bottom, where first we run our Sass loader, which compiles our Sass to CSS. Then we run our CSS loader, which translates our CSS to a common JS module, pretty much translates it to JavaScript. Next, we use our style loader, which then creates a style node, where it pretty much converts our CSS into the style element. All right. And what it then does is that it injects it into our HTML. So now our HTML got bigger. So next is another React file or file that has JSX in it. So we bring in our Babel loader. It does its thing. We already talked about it. So our bundle got a little bit bigger. Next, we're going to be doing a font. This is something that was interesting. So we bring in our URL loader. If you just left the loader as it is now, it's going to spit out a font, right? But it's actually going to add the font, the contents of your font, into your bundle. So your bundle then becomes bigger. So if you ever get those warnings, if you have a lot of fonts and you have a huge bundle, your chances are you're probably adding your fonts into your bundle, and that's what's adding to the size. So that might be one thing you can investigate later, but for now, it's added to our bundle. The last thing that we're going to be resolving is an image here. So with that, we use our file loader. What file loader then does, it's going to take, in this case, it's going to convert it to an image, and it's just going to write it to our dist directory or output directory. Don't worry about it. It's just know that it's going into our dist directory, okay? So now that's done, and now Webpack just has to do is put our bundle into our output directory, and that's it. So let's break down the other parts of the file. So we talked about the entry point already, so there's really no need to go over that, and we already went over the loaders in a way, so there's no need to go over the module section. But remember earlier when I told you to take note what's missing from this configuration file? some of y'all were probably thinking, where's the output configuration? Why did Fabian not put that in there? Isn't that important? So you're asking, where's this bit of code? Why am I not seeing it? That's because by default, Webpack automatically, or by default, sets the dist directory as your output directory, regardless if it's created or not. Meaning, anytime you crack open a Webpack file and you see the word dist inside of the output, chances are it's probably copy pasta from a boilerplate or hello world tutorial, because if you read documentation, you'll actually learn that you don't need that line if you're writing to the dist directory. It does it by itself automatically. Now the file name is important. I purposely left that out. Like if you want to add a hash to your file, your file extension, yes, like file names you still need. But as far as the path and having dist in it, that's unneeded. You don't need it. Just a wasted line in your configuration file. But anyways, if you look inside this folder, you'll see the JPEG and SVG. So just to tell you that Webpack will automatically put it inside of your output directory at the root level, or at the root. The next thing you're probably wondering is, where's the Webpack dev server? Where's all this code here? Again, Webpack provides some, they make some assumptions for the developer on what a developer would want for their dev server. So by default, Webpack automatically puts the port at 8080. So if you see the line dev server port 8080, you don't need it. Again, it has defaults for a lot of the common things that developers would want. So it's best to revisit your configuration file and start removing some of these lines and see if anything breaks. I'm telling you it's not. Okay, so earlier I said that task runners, the entire file was intimidating, right? But with Webpack, given that even before I went over, even before what I've already gone over, the part that's intimidating is the plugins. At least for me it was, because the loaders, they were pretty consistent to where you can kind of get an idea of what they do, but the plugins, they seem to take the form of anything. Like you can have a plugin that injects code into the into your output, kind of like this HTML Webpack plugin here. You have plugins that do like optimization. You have plugins that do performance, like benchmarking. Like plugins seem that they can do anything. And sure enough, from Webpack's documentation, plugins serve the purpose of doing anything else that a loader cannot do. That's good and bad at the same time. It's good because there's far fewer moving parts in your Webpack file than you would have in a task runner file. That's good, but it's bad because when something could be anything, it's really hard to understand what exactly it can and cannot do. So hopefully this next section will shed some light on this for you. So during Webpack's compilation lifecycle, aka building your application, it fires off these events for plugins to act on. So like the verbiage is plugins tap into these hooks. So I'm sorry, it fires off hooks, not events. So some of these hooks that it fires off are things such as like after plugin, before run, watch run, before compile, after compile. It emits these hooks or events, and plugins then listen for these events or for these hooks. So here's an example plugin. The first thing is we have the apply constructor. The next part, we're telling our plugin which hooks we want to plug into. So it's going to be the emit, run, and done. The next part is telling it what bit of code we want to execute whenever these hooks fire. Finally is how do we want that code to execute? Do we want the code to execute asynchronous, meaning Webpack is going to fire off our plugin and continue doing its thing, or do we want it to fire synchronously? So it's going to fire our plugin and wait until our plugin finishes before continuing to the next thing. Okay, with that bit of information, let's look at the plugin that we have in our configuration here. So it's the HTML Webpack plugin. I mean, really, if all you were doing was just to you don't even need this template. We're passing in a template variable or a property here. We don't need it if all we were doing was injecting our styles and our bundle. The only reason why this line exists here, so by default, if we didn't pass in any options, it'll still create an HTML file for us. The only reason why we're passing in a template is because our React is looking for, inside of our HTML, an element with the ID of root. So because of that, and since HTML Webpack plugin doesn't provide, when it provides or gives you its default HTML, it doesn't have an element with root. So we passed in a template for it to use. Here's what that template is. It's literally a skeleton HTML file. The only thing that it has is that element with an ID of root. So that's it. Webpack knows that, hey, so whenever it injects the styles, it knows to inject it inside of the head element, and as far as the bundle, it knows to add it to the bottom of the body element. So these are things. So these are things that Webpack does for you, so you don't have to worry about. That is what is different between Webpack and task runners. With task runners, this stuff here, you had to put in the code and look for these snippets to inject your styles or inject your bundle. So let's talk about some good practice. First thing, keep your build system up to date. The Webpack team is constantly pushing out updates to improve performance. There's no reason to leave that on the table. Now we're going to start going into my tangent. The next thing is configuration files are not programs. What I mean by that is many times you see what I see. The common practice is to pass in your environment into your configuration and let your configuration file handle which output it should be writing to, or if it should optimize for this. And so you pretty much have this configuration file that has all this logic inside of it. That is really bad, because it is not just you who will be maintaining this, but it's also going to be other developers, future developers. The last thing you want to be doing is adding complexity to a configuration file. Instead, what I would suggest you do is to separate your configurations by environment. And this is going to be the next thing that people who are doing this is going to feel really dirty as a developer, because you're so used to drying up your code, right? When it comes to configuration files, drying up your code can hurt you, because it is not just, again, it's not just you, but it's also going to be DevOps, system engineers who will come and pull up these files to tweak it to get better performance for some reason, right? So the last thing you want to be doing is adding, again, more complexity to your configuration file because you want it to be clever and write this if statement that you pass in the environment and it's just this nested object. Yeah, don't do that. It's okay to have duplicate code, just so long as you know that, okay, if I'm going to be updating my development environment, I just go straight to the development file and I make a change there. I don't have to go into the development file and then some other file. Now you can use Webpack merge, but I would do so wisely. If something is common between all your environments, such as the entry point, absolutely throw that in. There's no need to write that multiple times. It's not going to change. But if something does change, between environments, I would personally just write it 3 or 4 different times, depending on however many environments that you have. The next thing is keep configurations together. What I'm about to say, it's going to piss off a few people, and you're not going to know why it's going to piss you off, but I'm going to tell you to get rid of your .babelrc file and have them directly inside of your Webpack configuration file. Because, again, when you're dealing with configurations, there's no need to have configurations spread across multiple files. If you're going to be updating your Babel, if you're updating, so I experienced this when I was updating our Webpack at work from Webpack 3 to Webpack 4, and also updating from Babel 6 to Babel 7. What I later realized was, hey, I'm constantly making this update requires changes in 2 different places. Like I'm changing things inside of my Webpack and I'm changing things in my BabelRC file. Really, why does this BabelRC file exist if it can't do anything without Webpack to run it? So if you can pass in the presets and the plugins like I did earlier, and that when I was showing the Babel loader, there's really no reason to have this additional file. Again, it's not just you who's going to be making changes. It's going to be other developers like DevOps. So again, try to keep everything together so there's less moving pieces. The next thing is avoid configurations inside your NPM script. What I mean, and there's one exception to it, and we're going to be going over that later. The last flag is completely valid because you're passing in the configuration file. But the others, which are the hot flag, the progress, the mode development, get rid of that. You do not need to be having that in your NPM script. Add those to your configuration files. Again, there's nothing worse than when you're updating or making changes to your configuration file, needing to have 3 or 4 different files open because you insist on having flags instead of just setting the property inside your configuration. All these flags, you can put them in your configuration file. It'll work just fine. Okay, I'm off my tangent. Again, I have opinions. So let's talk about some notable plugins. The first one is case sensitive path. Now, if we'll just run through the example just from the name of it, I'm pretty sure you know what it does. So we have a header.js, or we have a header component that's inside of the source components directory, and we import it, but we accidentally import it with a capital H. If you have a Mac, hey, Mac knows what you're trying to do. It'll resolve it for you. It'll be like, hey, I know what file you're trying to get. I'll point you to that one. Don't worry. There's no need to stop everything. But this becomes extremely important whenever you're dealing with CIs or you're having the build system outside of your development environment. Like pretty much you're having things running in the cloud, right? That will throw an error. And many times has that bitten me where we'll push up a change, we'll merge it into master, and I'm coding up, and QA or quality assurance comes in and says, hey, that build never was pushed out. And I go and look at the build logs. Ends up I messed up on one of my paths. So I have to go in and push another commit just to make this small change. So save yourself the hassle and just have it inside your Webpack, especially if you're dealing with CIs. If it's like a local, a local hackathon type project, don't stress about it. But this to me has saved me so many times. The next one is Webpack Dead Code plugin. This one was amazing. I love this plugin. Now, you won't really get the benefits of it if you have like a 10-file project or 20 files, you're like the sole developer. You really only start getting the benefits whenever you have like 1,000 files and it's a long, it has this code base has been around for, 2 years, a year. You start accumulating these files that all of a sudden you kind of forgot about, and they're just kind of floating in the ether or whatever. So a Webpack Dev Code plugin tells you which files you're not using and which exports you're not using. So to me, when I joined Dragos, the code base is huge, and I really didn't know what was being used. But the code was going kind of like transition, writing static type checking. So there's a lot of things going on, and I decided to just add this plugin just to kind of see like, all right, what are we not using? We found over 70 files that were not being used. So again, this one to me, I really enjoy this plugin. So we went over a few things already. So Webpack's dependency graph, loaders, plugins, some defaults Webpack automatically does for you, some good practice, and some notable plugins. So now let's start having some fun. So what we're going to be doing now is benchmarking our Webpack file. Now, when it comes to performance, there's really only 2 things that matter. It's speed and size. So let's pretend that you start up this Webpack project and you just do like default hello world type configurations, like the basics, okay? You're gonna have like 200 millisecond builds. You're gonna have 50 kilobyte bundle sizes. Like it's gonna be awesome. It's gonna be extremely performant. But then as you add more and more modules to your project, you're going to start seeing that line go up exponentially. And this is bad. Like when I say speed, you're not getting faster. You're going to get slower. Okay. I know that I saw that a little bit later. I was like, oh wait, I need to change the verbiage here. But okay. Now, why is that? That's because remember that bundle, that dependency tree, you start getting modules that reference other modules and adds more complexity to your dependency tree. And so whenever you have, when you make a change to one file, Webpack has to go. It doesn't necessarily have to go and rebuild or rebundle the entire dependency graph, but it has to go and rebundle everything that was affected from that point. So now, all right, after a certain point, you have to kiss 200 millisecond builds goodbye. Like, it's not going to happen again. Like, there's no way for you to. So once your project gets to a certain size, I'm sorry, Webpack's not going to be able to build out your application when you have 1,000 files. Like, there's no way you're going to be able to import 20 megabytes worth of node modules and expect a 50 kilobyte bundle size. It's not going to happen. So you're going to have to make, I guess, compromises, I guess. So what you want to strive for is more of a logarithmic type growth where, yeah, after 1,000 files, let's say originally you have 1,000 files in your bundle, it takes Webpack 5 seconds to build out your application. Well, after all the tweaks, you're able to get that down to 1 second. On the next 1,000 files that you bring in, the next 1,000 modules, maybe you should be, you should be shooting for maybe 1.5 or 1.8 second build times. Now, you do have to realize that speed and size do affect each other. There's no way you can have no way you can shoot for having the fastest build and still expect to have the smallest bundle size. It's not going to happen. So you need to decide as the developer, okay, in which context does this matter more? For me, and I'm assuming for you, during development time, speed is what matters. When it comes to production, that's when size happens. That's when size matters. As far as for me, whenever it's in production, it can take 2 hours to build. I don't care. That's happening in a CI somewhere, not on my computer. It's not bothering me. So, except for me, I cannot afford to have my team wait 5 seconds anytime they hit save. Now, I'm actually going to draw on this slide. This is something new, so don't freak out here. So, you kind of see this line here, right? I don't know where this line is, where to draw this line. I don't know if that's 50 modules, 100 modules, 500 modules, 1,000. I don't know where that line is. But what I'm telling you is, when you're first starting off, you shouldn't be trying to optimize your Webpack configuration file, because you don't reap the benefits until you start getting over here. So initially, if you start doing tweaks, you're going to find yourself following this line, and you're actually costing performance, because Webpack is going to be doing all this extra work when it could have just bundled it all together and been far more performant. So now that we talked about, we put the math out of the way, let's talk about measuring. Now, before you go and start making tweaks to your configuration, it's best to know what's even going on in your code base. So get an idea of the layout. Get the layout of the LAN. There you go. So here I use the clock node module, and it gives me a breakdown of all the languages, the number of files, number of lines. We end up having over 1,000 files. We have almost 250,000 lines of code, just so I can get an idea. So whenever I come, 5 months down the road, I make a change. I get rid of this huge directory. I can see how has our Webpack been affected? How performant has it become now that this bit has been removed? We also have 40 dependencies. I just pulled that from package.json. What I'm pretty much saying here, get an idea of what your project looks like before you start making tweaks to it. All right, so the first tool I'm going to talk about, and this is a must-have tool, regardless if in that graph you're at the 20 module mark or if you're at the 100 module mark. It's the speed measure plugin. So as you see here, it breaks down the timing of your build process. It helps you identify what parts of your build process is slowing you down. So this is good. This is a way for you to know, like, okay, well, the Babel loader is taking 4 seconds. Like, this is really, really long. Maybe I should check to see, has anyone else complained about this? Maybe there's a new version. So by the way, by having speed measure plugin, you're going to find yourself in parts of Webpack's documentation you didn't even know existed, because you want to, okay, how can I make this more performant? So let's talk about some speed tips here. The first one, which is like, is the avoid anything that has the word minimize. So when you have something like you have the word minimize, that means Webpack's going to be doing extra work It's going to be using extra CPU cycles to try to get this thing as small as possible. You don't want that. When you're in development mode, you want it as fast as possible. Give me the whole file with the comments. I don't care. The next thing is use style loader. Now with style loader, I mean, these are milliseconds I'm talking about, but you know, every millisecond counts here. So if you're having JavaScript, if you're having Webpack having to write your CSS into its own file, like IO operations are very expensive. You have to read or write to a file, so it's best to just have it. If it's gonna write, you might as well just inject into the HTML. That way it's all in one file. It's one less file for your browser to take in. The next thing is split your node modules into its own vendor bundle. Well, what I mean by that, and if you don't know what this is, just Google split chunks, and documentation or Google is going to point you in the direction. But why this is important. So remember that dependency graph? Not dependency graph, the bundle and the dependency graph inside of it that it consists of. I'm going to be bringing that up a lot, by the way. Remember how node modules were in there? The thing is, if your node modules aren't changing, there's no reason why Webpack should have to rebundle those because you made a change to your header.js file. What you should do is you should move those modules out into its own bundle, because you're not going to make changes there, so there's no reason to have it included. So that way, whenever Webpack does rebuild your bundle, or it doesn't have to also include and make rebundle those modules as well. The next thing is to use hot module replacement. Now, when I first learned about hot module replacement, I thought that it was like, is this Webpack's way of saying live reloading? Why not just say live reloading? But it's actually not. Most of you will probably already know what it is, but in case for those of you who don't, I'm still going to go over it. So with live reloading, it reloads your browser. Okay. With hot module replacement, it does not reload your browser. It just goes and takes out the little bit that needs updating and updates right there. And so to give you an example, let's pretend you're filling out a form and you're 10 text fields in, and you want to change a label, the label of an input box. Well, if you use live reloading, when you hit save, your browser is going to refresh and you're going to lose all that information that you already typed in, right? Like, versus if you use hot module replacement, it's just going to go and make that little switch for you, and you can still continue without losing your state. Now, here's a library that I've used before, or that I do use, is React Hot Loader. And here's how this is how much code. This is it. If you wanted to get hot module replacement in your React project, this is all the code that you need. Now, there are limitations to React Hot Loader, and I'll tell you that they have to do with your lifecycle methods, but it's listed in the documentation. I'll let you look into that. I'll leave it up to you to look. I'm not going to go over it. So now let's talk about measuring size. Now, so if you ever ran your Webpack in production mode, chances are you probably have seen this warning telling you, hey, your bundle's too big. And you're just kind of standing there like, all right, cool. What do I do now? Like, I guess maybe I'll start commenting out code. I don't know. So just as we added a plugin to help us measure speed, we need to do something similar to help us measure size. Now, earlier when I said there's that one exception to add configurations to your NPM script, this is it. So it's the same configuration, but instead we're just adding the profile flag here, and we're telling it to write to the stats.json. So whenever I run this command here, what ends up getting spit out the other side is the stats.json file. And you're probably sitting there now is like, all right, cool. What do I do with this JSON file? So now we got to take this JSON file and bring it to a tool to help tell us, okay, what's going on in our configuration file. Here, this is from Webpack's documentation. It lists out a few bundle analysis tools, I guess you would say. Now, there's tons of these on the web. Like, there's some that of course run in the browser, some that run in the terminal, some that are standalone apps. There's a lot. Now, I will say this, another opinion, I'm sorry. From what I've seen, there's a lot of graphic overload central, where it's like just animation, and it's just like this. If I have to wait 1 second per animation, Like I'm not going to be happy at all, because when I'm in these tools, especially because there's a lot of graphs and charts, you're going to see one here in a bit. Like I'm not just clicking once or twice. I'm clicking like 4 or 5 times. I have to wait every second, like 1 second per click. I just, no, I don't want to deal with that. Now, there is one that it's really, really cool that I like it. It's Webpack Bundle Optimized Helpers, the last one on the list. It actually gives you suggestions, which is really awesome. Though the suggestions that it has told me is, hey, I see that you're using Lodash. Maybe you should try importing like this because of reasons X, Y, and Z. And also another suggestion is over the Moments library, which is a date library. But yeah, so these tools, they're not just to tell you numbers. Some of them give you suggestions. It's pretty cool. Now here's the first one. This is Webpack's official analyze tool. It's really basic, really simple. Nothing wrong with that. I just wanted to show it just because it was the official one. The next one is my favorite one. It actually lacks a lot of the features that others have, but the reason why I like this one is because not only is it really, really fast, like it's not only is it very fast, like it just gets straight to the point. That's all I really care about. But I can easily switch in between my bundles, right, using this drop down. But more importantly, which this is why I like it, is because it lists out the bundle sizes to the right, which makes it 10 times, 1,000 times easier whenever I need to run down this list and find the bundle that I need to investigate because it's just way too big, right? So, okay, we have an idea of what our code looks like. Let's talk about code splitting. Now, code splitting has taken, like, at least for me, like doing the research, seeing the videos over it, kind of like takes it's taken the form of like a buzzword, really, where it's like, do you code split? Like, you don't code split? Man, you should totally code split. But the thing is, there's more to code splitting than just code splitting. And what I mean by that, I'm not gonna go into the real in deep into code splitting, but I'm gonna highlight some key points. So, well, first let's explain the problem. Let's say at the beginning, before any optimizations, your bundle was 5 megabytes. And after like 20 hours of optimizing, you're able to get it down to 2 megabytes, which is still, according to Webpack, really big. And not just according to Webpack, that's still a really big bundle. You need to shrink that down even more, but there's nothing more that you can do. So as code splitting suggests by its name, instead of having one 20 megabyte file or one 2 megabyte file, you split that down into 20 100 kilobyte files, right? Now, here's the thing. It's not just about adding a code splitting library to your project and expecting that, like, oh man, like my code has been split in the most optimal way. No, it doesn't work like that. And that's the reason why I say it's kind of taking the form of a buzzword, which, like, do you code split? There's another thing that you need to think about when you're code splitting, and that is where you code split. Now, as far as the approach that's taken, we're going to be talking about where you code split in a second here. So the most taken approach is to use dynamic imports. I'm not going to go over as far as dynamic imports because it's beyond the scope of this presentation. But we have a regular import statement. That is a dynamic import statement. Know that since Webpack 2, Webpack automatically code splits any dynamic import statement for you. It's another default for Webpack that Webpack does for you, so you don't have to worry about it. So if you can get that line to work in your code, you can start code splitting right now. But of course, with any technology when it comes to JavaScript, there's gonna be a library or framework. The one that I've used is React Loadable. What I like about it is because it allows you to have a loader. If something's still loading, like it'll put a placeholder of like, hey, this part of your code's loading, right? So it's like, all right, cool, awesome. Now, let's talk about where to code split. This is the part that I was going to be talking what I was mentioning earlier. So when you read or whenever you're looking into code splitting, the first thing they're going to tell you, like the most, I don't want to say naive because it's not naive, but it's a code split at the router level, because that's part of the application where, like, let's say you have 5 pages, well, you can end up getting 5 different bundles just off of that, right? So I'm not going to call it a naive approach because it's still a solid approach, but that is like that's the first, swing at code splitting that you can do, just to kind of see what type of results you can get from it. So that's what I did to our bundle here. So this was the bundle before, and I know those numbers are small. Don't worry, I'm going to read them out to you. So the vendor.js was 1.7 megabytes, and app.js was 1.9. What I'm about to do is do the router level code splitting, and this is our bundle now. As you can tell, we have a lot of routes. So the vendor.js dropped from 1.7 to 1.5, and our app.js went down from 1.9 to 1.4. So clearly it's an improvement, but now having done it, thinking about it, I actually know where there's one other place that will improve code splitting like 10 times than this, in addition to this. But as you kind of see, like if you actually were to add up all these numbers, if I were to add up all the code splitted numbers plus the app.js, it's going to equal like 3 megabytes. When before, if I were to just do, if I were to not code split, it would just been 1.9. But the reason why, is I think I know where else I need to code split. Now, I will say there was at one point I was able to drop down app.js to about 200 kilobytes, and that was really cool. I don't remember how I did it though. I didn't commit it. This is where you commit your code, because I went back and I tried to make the tweaks, and I was like, why is this not doing it anymore? But yeah, I don't know, maybe it didn't bundle it correctly, but I remember seeing app.js 200 kilobytes. That was it's a good day. So let's go over some references on things that I used to build this presentation. And this is actually the first time for me this ever happened. Like I literally just built this entire presentation off of Webpack documentation and one other reference, which was in this case a book, which is Survive.js Webpack. Now, I'm going to be talking about that in a bit, but first let me just talk about documentation. When it comes to build systems, I know this part, if you need to listen, this is the part you need to listen to. When it comes to build systems, you're better off just reading. You're better off setting aside 3 hours and reading documentation. I did that. Yes, it's not that bad. Webpack actually does a really good job, doing storytelling to help you understand the tool. You're better off doing that than relying on Stack Overflow answers. Because when it comes to like build systems, configuration files, all that, you either know it or you don't know it. It's a black or white type of technology. It's not like, for loops, functions, callbacks that you practice them to become more comfortable, more familiar with them, and understand like, okay, this would be a good time to use this. That's not the way configuration files work, or learning configuration files. You're better off just reading it, and you either know it or you don't know it. You know where to look, or yeah. Now, again, I'll say with like 90% confidence that the Stack Overflow questions that you're going to be referencing, with 90% confidence that those are not the answers that you're looking for. Reason why, because you have two things working against you. One, it's a different project entirely. So you're going to see things in those answers that don't apply to you. So that's one thing that's going to confuse you. Second thing is that Webpack breaks a lot in between versions. So you're going to copy this answer and you're going to put this Webpack 2 answer into your Webpack 4, and it's going to yell at you, and you're going to be like, oh, well, it looks like I need to go click on another Stack Overflow answer, versus had you just read the documentation, you would have known, oh, I need to use this plugin instead of that. Now, if documentation is not your thing, then read Survive.js Webpack. Like, hands down, the best book that you need to read in order to become a Webpack, grandmeister, right? It doesn't matter if you know Webpack, or if you have very little experience with it, or even if you're comfortable with it, you consider yourself a master. I would read this book. You will walk out. You will finish. Once you close the book, I did an ebook, so close the window. You're gonna feel like a master. You're like, dude, there's nothing in this file that I don't know how to do. So yeah, those are my two references. The last thing that I'm gonna mention is that if you're gonna watch videos over Webpack, watch presentations, not just tutorials. Like as I kind of already mentioned, Webpack is not something that you get better at. You just know or you don't know. So it's not something that's monkey see, monkey do, which you kind of see tutorials do, and they don't really explain it. That's why I like to watch presentations, because those presenters really have to understand the technology. Now, if you don't know where to start, hit me up on Twitter. Chances are I'm probably going to redirect you to this presentation. No, I'm just playing. But hit me up on Twitter, and I will point you in the direction, where you're at and what you need to know. How I can help you as best I can. Now, the last thing I'm going to mention to you, and this is actually a conversation that we had before the presentation, is you don't need to become a Webpack specialist to be a great JavaScript developer. please understand that you don't need to, if you have multiple things inside of your list, inside your, list of things I need to know, Webpack, depending on if you're already in the field, if you already have a software development job, or if you're already in there, then by all means learn Webpack. That will get you from a junior developer to a senior developer for sure. Not this technology alone, but that's a step along the way, step in the right direction. But if you're trying to break into this field, Webpack should be the last thing that you should be trying to learn. Instead, you should be focusing on building a good software development foundation, understanding good programming principles, than trying to, instead of doubling down on Webpack. Now, again, I'm not saying it's not important to learn, but if you have other things that, if you want to get better at promises, I would put promises before Webpack any day to me, because if I'm interviewing a developer, yeah, okay, cool, Webpack, but how do you feel about, promises? That to me is more important, because we already have a Webpack guy on my team. It's kind of looking at him here, but like if you can learn it, it'll be cool. But most teams that I've encountered, they already have someone that takes care of the build system. So to me, if you're trying to break into the field, just become comfortable with it, become cool with it, but there's no need to become a master at it. With that, I am actually done. Here's my Twitter handle in case anyone wants to get in contact with me, but we're gonna go ahead and open up the floor for any questions. I don't know. What are we going to do first? Okay. Yes. So. Okay, so the question for the recording, just that question was, why did I say get rid of the babelrc file? The reason why I believe you should get rid of your babelrc file, the only reason why it even still exists the way that it does is it's like inherited technology since 2014 or 2015 when it was created. Like we needed to have a .babelrc file, so you just become accustomed to having a babelrc file that we need to always have one, right? But Webpack gives you the option to set all your Babel configurations inside of the Webpack file. So there's really like, okay, yeah, you can have it exist in this other file outside of your Webpack, but when you're dealing with Babel loaders, which by the way, what is that? The only thing that interacts with your babelrc file is your Babel loader. So to me, just thinking about that, well, why am I calling the babelrc configurations over here in my Webpack file, but I have the babelrc configurations living in its own file out here. So just put them together, and I have one file instead of two. So that's the reason why I said that. But it's a good question. Anyone else?
I think I showed in there, like, I was messing around with Babel 7, and there's documentation that say don't use an RC file.
Really?
Yeah, they want
so
you to use a Babel config.js.
Hell no.
Actually, I think today I'm like they're emulating Webpack.
Okay, so all right, so the comment, the video is going to be hearing me say hell no just under my breath, but the comment was that Babel 7 somewhere in the documentation it says that to not have a babelrc file, but instead introduce a Babel configuration file. Is that correct? Something like that?
I think it's looking by default look for babel.config.js.
Okay, babel.config.js. I'll look into that. My opinion is if I'm going to have one, if the technology cannot live on its own and depends, solely on depends on another technology, like Babel cannot do anything without my Webpack setup, at least in my project, I might as well just combine the two and have them in one place instead of two. But yeah, I'll definitely check that out now. Is anyone else? Please don't tell me that there's no questions, because I'm going to say this. Webpack has been by far the most requested presentation in this meetup, so I expect to have multiple questions here. Well, Brandon was first, Dan. So I'm sorry. Yes, Brandon.
As far as code splitting goes, you mentioned comments you split per page. How does your build influence the actual HTML that's rendered? If you're in a single page application, you're now refreshing the page. How is that bundle distributed?
So good question. So the question is, how does, if you have a single page application, how does having multiple bundles affect, your application, given that you're not going to be loading, you're going to be switching in between your files. Now, this is where Webpack's bundling magic comes into play. So with dynamic loading, it doesn't have to load the bundle on initial load. It can fetch it later at a later time. So like how it does it, I couldn't really tell you because that's inside of Webpack's code. Not that it's proprietary or anything, but it handles it for you. So if the concern is, Fabian, I have a single page application. Will code splitting affect my application to where it's going to be reloading the page? The answer is no, it will not. It will still act the way it is currently now, as with one bundle. Dan?
Yeah. So I already have to ask too many questions. But
okay, we got a lot of questions coming up.
The size and speed of the metrics were awesome. We don't do anything like that here. That's something we need to do. Have you successfully incorporated that into your CI system so you can say, I want to look at how much has my bundle size increased or decreased over the last 6 months?
Okay, so the question is, for the recording, is have I created benchmarking into our development cycle? Short answer is no. The reason why, so whenever I, spiked, or when I learned all these tools, it was for this presentation, and I had my own branch in the code base that's like, do not touch this branch. This is Fabian's Webpack branch. Do not touch it. So I haven't gone and like taken this technology and like really applied it to see how it'll look in the system as a whole. But as far as what you're asking, which is like, measuring your bundle over time, like over the course of 6 months or something like that, like I find that extremely valuable. Now, have I done it yet? No, but it's like, yeah, like if I just force it into doing, if I force doing that, it's not going to be the solution. I kind of want it to happen organically, where it's like the question comes from, from leadership or from DevOps or system engineers. We're like, hey, we kind of need these numbers, and then I'll go and implement it. But it's a really good question. I just haven't done it. What's the next question? Or is that it? Okay.
So you're saying you shouldn't put logic into your Webpack config files, right? So how do you guys, or how do you handle like having like config, or having different like settings or configurations for like testing versus like production versus development for your Webpack?
Good question. So I said don't have logic inside of your configuration files. I didn't, or not that I purposely didn't mention it, but I kind of just went over that line in the notes, which is like we have multiple configuration files. Like we have development, we have production, we have QA testing. Now, the reason for it is so that way whenever I need to make a change for example, we needed to add hashing to our files. Instead of so with hashing, you can hash on the build, or you can hash. There's two ways you can hash. I forget which. There's just content hash and then hash, but one of them is meant for production and the other one is meant for development. Or you're not supposed to use one in production, or vice versa, something like that. I just go into that file and I'll make that change instead of having to like insert some logic that says, if, is production, do this, colon, then do that. And you have like is production, is development, is testing. It's like at this point, you might as well just have 4 or 5 configuration files. But yeah. Yep.
So like one thing that we've done is we put out the common configs into a base config.
Same here, yeah.
So I mean, there's some variation, but you can save 40%, 50%.
Yeah, if something is consistent, so the comment being, you can have like a base Webpack, and in the slide, even though you're not going to be able to really see it, I do mention, where is it? If you can see it, there it is. So I do mention Webpack merge. That's a viable option as far as reusing configuration. So like for example, like the entry point, or like Webpack clean plugin or something, like plugins that you for sure use across the board. Yeah, throw those inside of a base one. There's no need to copy and paste that. But as far as like the differences, what I've seen a lot is people put if statements or ternary operators. I can never say that word, so I gotta. Yeah, like. Yeah, and it's just like just don't do that. Like I used to do that. Don't get me wrong. I'm not standing on like on a high horse here saying that like, no, that's bad. But like after reading this, or not after reading, but like after doing this presentation and just having the experience, the experience that I've had with configuration files, it's just like why put the if statement? So for example, like when you look at like a Jenkins file, like I looked at the build process in our backend tools. It's a script that reads like English. Unfortunately, you can't really do that with Webpack because it's JavaScript at the end of the day. But like I read it and it was literally just reading like English. It wasn't like a if this, do that, if no, it was just like top to bottom. They had multiple configuration files. And I was like, this is a really simple way I can come in here. I'm not even familiar with the technology. I'm not familiar with the build system, but I'm looking at it and I know exactly what it's doing. So it's like kind of take that practice into to JavaScript. Does anyone else have any questions?